Okay, so we'll say that a function has a vertical asymptote at x equals k if, as the x values get closer and closer to that particular number, the y values are going up to infinity or down to negative infinity. So we've seen this before with the 1 over x function. Here, as the x values get closer and closer to 0, the y values are going up towards infinity. And let's actually calculate them here with the data table. So first, notice that here x values are getting smaller and smaller towards 0. 1/2 is less than 1, and 1/10 is even smaller, and 1/100th is even smaller. Okay, what happens when we plug these values in to find y? So I could plug in 1, I could plug in 1/2, I could plug in 1/10, plug in 1/100th. And remember, when you divide by a fraction like this, you would invert and multiply. So here I have a y value of 1, here I'd have 2 and 10 and 100. So as the x values are getting close to 0, the y values are going up to infinity. So right away, let's write that down. If you want to know what is it that's making the y values go to infinity, it's the fact that we're dividing by smaller and smaller numbers. If you're looking for one thing to hold on to in this video, that is the thing that you want to be thinking. It's not going to be necessarily a process. There's not going to be a particular test that you use. You want to think, what makes y values increase? It's going to be dividing by smaller and smaller numbers. Okay, let's go back up to the top, though, and write what our definition is. So we said that a function is a vertical asymptote at x equals k. And if you saw the last video, k is just some specific number, such as x equals 0. Okay, what does it mean to say x equals 0? If I draw a vertical line at x equals 0, all the points along that line have the same x coordinate. So that's what we mean when we say there's a vertical asymptote at an x value. And we said that as the x values approach that k, and we're not going to think about approaching from the right versus the left. Let's just leave that informal for the moment. So as the x values get closer and closer to k, the y values are going to go up to infinity or negative infinity. If it would help you to write down in English, you could write down in English. All right, so you might wonder, all right, as the x values are getting closer to as the x values are getting closer to 0, the y values go up to infinity. What happens if the x value actually gets to 0? What happens if we actually go right on top of the asymptote? So if I plug in 0, I would be dividing by 0, and that's undefined. If you're wondering, I made another short video about what does it mean to be undefined and how do you think about that. We're not going to do that right now. But the fact that it's undefined is why you don't actually see a point whose x value is 0. It's because there is no y value when x equals 0. All right, so I want to show you a contrasting example where the y value at 0 is also undefined, but there's not going to be a vertical asymptote. So here's 1 over x. Let's just make the sketch again, just so that we have it here to contrast. So there's 1 over x. And let's imagine the graph of x over x. You might want to sketch it for yourself, if you'd like. So let's think. If x is 2, I'll have 2 over 2, which is 1. If x is 1, I have 1 over 1, which is 1. If x is a half, I have half over half, which is 1. If x is 1,000th, I have 1,000th of 1,000th, which is 1. So it might seem like, oh, this graph is actually just a horizontal line at y equals 1. Except at x equals 0. If x equals 0, I have 0 over 0, which is undefined. But I'm not going to have a vertical asymptote here. I'm going to put an open circle here, which is a hole in the graph. Another name for a hole is a removable discontinuity. We'll come back to that name in a second. Let's just convince ourselves that for the other x values, we also have a horizontal line here. If x is like, let's say, negative 1/10, negative a tenth over negative a tenth is positive 1. So this really is the line at y equals 1, except for a hole right there. All right, let's contrast that over here. We've already seen here that at x equals 0, we have 1 over 0, which is also undefined. Okay, so if you want to know, like, what's the difference between there being a hole and there being a vertical asymptote, it's not about what's happening at x equals 0. In both cases, you get an undefined number at x equals 0. So what's happening with these discontinuities isn't so much about the value where it's undefined. It's going to be about what's happening to the y values as you get closer and closer to that number. So here, as the x values get closer to 0, the y values increase to infinity, whereas here, as the x values get closer to 0, the y values are just staying at 1. So that's the difference between a hole and a vertical asymptote. You can't think about what happens at the particular number. You have to think about what happens in this process as you plug in x values that get closer and closer and closer. So that's going to be your takeaway from this video, is the idea that you have to actually imagine plugging in values closer and ask, what's the trend in what the y values are doing? I hope this helps. Good luck on the problem set.